Okay. Well, very good morning, guys. Yeah. Last class, I just explained you about okay. So last day, I just been explained you about projects, adding new projects, and also compilation of the projects, right? So when you compile a project, what it generates you? An output file called as assembly. When you compile a project, it generates an output file. We call that output file as a assembly. And I explained you the location where the assembly files will be present for you. And I said you the name of the files. Name of the file will be project name only. Second thing is extension. The extension is application projects will have .exe. Library projects will have .dlls. But when you come to .NET Core, application projects will create you .exe, .dll also. These DLLs are introduced newly for executing on Linux and Mac machines. How to run them also I shown you. Now, what did I say yesterday, guys? If you take an assembly file, the assembly file will contain all the types. The assembly file will contain the IL code of all the types. In our OOPS project, how many types are there? We counted 44. So 36 files and 44 types. In the 38 are classes, 2 are structures, and 4 are interfaces. Totally 44. The IL code of all the 44 types will be present in that assembly file only. Did you understand me? The IL code of all the 44 types will be present in that assemblies only. It is going to be present inside of that assemblies only. For example, all of you watch. Look here. Open the developer command prompt. Yeah. Now in the developer command prompt, go to your folder. What's your folder? E drive. C# 10. OOPS project. Pen. Debug. And what is the assembly folder? Net 6 pointer. Now here we have the assembly file. See that these are the assembly files. .exe, .dll. We have one more file called PDB files. What the PDB files are? The PDB files are actually used for debugging the code. We don't require them. We are not going to install them on the client system. It is only for debugging. F5, F10, F11. For that we require the PDB. So we need on the developer machine, but they are not important for us. So what is important is only these two files, DLL and exe. EXEs will directly run. EXEs will directly run. As I shown you in the last class, you can directly run EXE. See that you got the output. EXE files will directly run for you. You can see the output. Directly EXE is executing and giving you the output. Okay. And when you come to DLL file, we cannot run a DLL file. We cannot run a DLL file directly. If you try to run, you get an error. Could not load the file or assembly. Are you clear? You can't run them directly. But these DLL files you can run on Linux and Mac machines also by using a tool. What I said? .NET. But remember, DLL files generated by libraries. DLL files generated by library projects will never run. What will run? DLL files generated by application projects only will run. Understood the point or not? DLL file generated by application projects only will run. But the DLL file generated by libraries will never run for you. Okay, fine. So all these things I shown you in the last class. Now you see, we have a tool called ILDASM. Stands for Intermediate Language Disassembler. Intermediate Language Disassembler. For this, give the name of your DLL assembly name. When you run that, it will explore the assembly. It will explore the assembly and will be showing you the contents of that assembly. It will explore, understand here the name of the tool, disassembling, assembly, disassemble. So it will explore the assembly and it will be showing you the whole contents of the assembly. Watch. Yeah, have a look. What do you see in the top? Oops project.dll. What is that? That is your assembly name. Another day, again you have oops project here. What is that namespace name? Under the assembly we have the namespace. Under the assembly we have the namespace. Assembly is a physical container. Namespace is a logical container. Assembly is like a drive. Namespace is like a folder. Folders are not physical. Folders are logical. Are you clear? So this is your namespace. Now under this namespace, you have all the 44 types. When you explore the assembly, guys, you'll find the whole information. Now you count here, you'll find all the 44 types here. All the 44 types will come here, see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44. Total 44. And all the blue color icons are classes. Watch. All blue color icons are classes. Brown are structures. Brown is structure. See, a brown has structure. A blue with I, a blue icon with I is interface. How many interfaces are there? 4. 2 structures. 1, 2. Remaining all classes. Remaining all are classes now. Is that clear? You can explore an assembly like this. You can explore a assembly like this. Any assembly can be explored in this way. Any assembly can be explored in this particular way. Okay, so observe this once. What? Just a second. Yeah. I'm again back into this folder. Which folder? Second project's been debugged. Okay. Watch ILDASM. I'm exploring the second project.dll now. If you observe this, again, assembly, and this is namespace. We have only 2 types here. Class 1 program. This is what we added yesterday, remember? Under that we have class program, under that we have class 1. Both the 2 things. Okay, now. So what I'm trying to tell is the single assembly file will contain the IL code of all the types. The single assembly file will contain IL code of all the types. The IL code of all the types will be present for you under the assembly only. Which assembly? Which assembly? the .dll, the oops project or second project, whatever it is. Under that, you will be finding up everything under that. Okay, now, are you clear with assemblies, all of you? Okay, next. The next thing what we are going to learn today is, listen guys, can I consume, answer this question all of you. Can we consume the classes defined in a project from another class in the same project? Answer the question. Can we consume the classes defined in a project from another class in the same project? Yes or not? Yes. We know that we can consume, and that too in two different ways. We can consume in two different ways. What are the two ways? By using the race inheritance and instance creation. We can consume them directly in two different ways. That is inheritance and instance creation. Okay. Now the next question is, read it. Can we consume the classes defined in a project from a class in another project? I want to consume from a class in another project. Understood the requirement? Concentrate here. Don't look into the notes. Okay. So what's the requirement? We want to consume the classes defined in the project from another project. Another project is our requirement. For example, say in our oops project, we have a class called rectangle. 2 days back, you defined your figure, circle, cone, rectangle, and all. I want to consume this class. I want to consume this class from where? Second project. From where? Second project, class 1. Are you clearer or not? What I wanted to do? I want to consume the rectangle class which is present in oops project from class 1 of second project. Are you clear with the requirement? Come on, let's do. Let's try. So this is class 1 defined in second project. From here I want to consume. So to consume it, I'm going to create the instance of the class. Which class? Rectangle class. Rectangle. Guys, watch this. When you're typing here, IntelliSense has to show you that in the list. IntelliSense has to show you in the list. Is it showing? So you can consume. Or if IntelliSense is not showing what you're typing is wrong, yeah. If you type there, you'll get error. Are you getting my point or not? So if I type, I'll be getting the error. So now the doubt arises. So can we consume the classes of one project from another project? Is it possible? Because when I type, I'm not getting it list here now. Are you clearer or not? When I'm typing, I'm not getting the list here. So the doubt arises is, can we consume the classes of one project from another project? Okay, listen guys. Actually, we can consume them. We can consume them. Option is there. But we are not getting it. Just watch it. Yes, we can consume them, but not directly. That is, to consume them, first, we need to add the reference of the assembly in which the classes are present to the project who wants to consume. Read that carefully, all of you. Did you guys understand that? What is it telling you? The reference of the assembly, in which the classes are present to the project who wants to consume. First tell me, rectangle class is present in which assembly? Oops project assembly. That assembly reference should be added to who wants to consume? Second project. So that assembly reference should be added to second project. Are you clearer or not? Okay. Say, for example, the reference of which assembly? Oops project assembly should be added to second project. Should be added to second project. Okay, watch it. How to do that? Watch carefully. Look. Who want to take that reference? Who want to take that reference? Second project wants to take that reference. Whose reference? Whose reference? Oops project. Okay, whose reference? Oops project. So what to do? Right click on second project. Right click on second project. Add. Project reference. Add project reference. Click on this. Once you click on this, it opens a window. It opens a window. What is that? Open where first? Reference manager. In that, go to browse. Go to browse. After going to browse, come down, click on the browse button. When you click on the browse button, it opens you the file dialog, open file dialog. It opens you the file dialog control. So now select the assembly from its physical location. Select the assembly from its physical location. Yes, guys, where is it? E drive. Louder. C#10. Oops project. Oops project. Pin. Debug. Net 6.0. And you generally add the reference to the DLL files. References are added to DLLs. Yesterday I said, yeah, DLLs are always support files. They'll provide the support. So you're taking the support of the DLL now. You're taking the support of the assembly. So generally, when you want to run exe, guys, when you want to add a reference, DLL. You're required to add the reference to which file? DLL file. Click on add. Click OK. And after doing this, observe it, all of you. Come to the Solution Explorer. Concentrate. Go to second project. Your dependencies here now. Expand the dependencies. Can you find assemblies? Expand it. The reference of the oops project is added there, will be shown to you. Are you clearer? It will show you the assembly references that are added for this. You added the reference of the oops project. Dependency, our second project depends on oops project. So now, can I consume that class now? Yeah, you can consume that class now. You can consume that class. What is the class? Okay, now also not coming. Now also not coming. Actually, now why is it not coming is, reason is not about adding the reference. Adding reference is compulsory. Adding reference is compulsory. So, why you are not getting it is because these two classes, which class? Class 1 and rectangle, are present on two separate namespaces here. Class 1 is defined in which namespace? Rectangle class is defined in which namespace? That is the problem. Are you clear? Oops project dot. Got it? Without adding a reference, if you type oops project, you won't get that. Remember, without adding a reference, oops project will not come in the list. Are you clearer or not? So I want to create the instance of the rectangle class. Oops project dot rectangle R is equals to new oops project dot rectangle. Okay, it's the parameter values. Pass the parameter values. Are you clearer or not? What are you passing? The width and height. You're passing the width and height. Yeah. But see the problem, guys. 2 times I'm writing oops project dot, oops project dot. If I don't write, I get error. Red line key. So that's why to overcome this problem only, I said, what is that? Without writing for multiple times, come to the top and write what I already explained to you. Simply write using oops project. So no need to type again oops project dot every time now. Import the namespace and we can just directly consume it. Is it clear, all of you? Okay, now if I ask you a question, how to consume the classes defined in one project from other project? What's your answer? How to consume the classes that are defined in one project from other projects? There are 3 steps here. Step 1. Add a reference to the assembly in which the classes are present. Add a reference to the assembly in which the classes are present. That is step 1. Step 2. Step 2. What is step 2? Import the namespace. Import the namespace. Step 3. Either create the instance of the class or inherit the class and consume it. Understood or not? What is steps to consume? Steps to consume classes defined in one project from other projects. Step 1. Add a reference of the assembly in which the classes we wanted to consume or present. Is that clear? Step 2. Import the namespace under which the classes we wanted to consume or define. Import the namespace. Step 3. Now, either create the instance of the class or inherit the class and consume the classes. Are you clear? First I added the reference. Later on I imported the namespace. After importing the namespace, I started consuming the classes. Okay now? Okay. You can see, guys, I want to consume all these classes. What are the classes? First class, rectangle. Second class, circle. Third class, cone. Fourth class, triangle. Run. Guys, if you don't import the namespace, all of you, carefully listen. If you don't import the namespace, do you know what happens? You're required to prefix oops project 8 times. 2 times before rectangle, 2 times before circle, 2 times before cone, 2 times before triangle. Totally 8 times you just required to prefix it. Is it for all of you? So to reduce that burden, what are we doing? Once we are importing the namespace, comment this, guys, comment this. All this 8 will be errors now. See there, 8 errors. 8 times writing oops project is easy, or importing is easy, That's what. Any doubts? Understood all of you? First step, add a reference. Second step, import the namespace. Third step, either create the instance or inherit and consume the class. Create instance or inherit and consume the class. So this is the process of consuming the class from the classes. Okay now? Here, guys, I require to clarify some few things here. Generally, when you're working with this, guys, we have few confusions here. We'll be coming across a few confusions. What are the confusions? The confusions are, you face confusion between these 3 things. You guys face confusion with these 3 things. What are the 3 things? Project name. Okay, next. Assembly name. Next. You always face confusion with these 3. Why? All have the same name only. Hey, what's your project here? Oops project. What's your assembly? Oops project. What is your namespace? Oh, tell me, don't you have confusion with the 3 now? Tell me, don't you have 3 things? Yes or not? So generally, everyone will be facing the confusion with these 3 things actually. Everyone will be facing confusions with these 3 things generally. Generally, you'll be coming across confusions with these 3. Okay. Now the question is, let me clarify here. Let me clarify all the things. See, listen. Project, actually, a project and assembly are one and the same. Did you understand me? Actually, a project and assembly are one and the same. One and the same. Okay. That is, project contains source code and assembly contains compiled code. So we'll have the same name and cannot be changed. Pretty clear, guys? Are you clear? You've written a program in C language, test.c, compiled it, test.exe generated. What is the difference here? Both are same only. One will contain source code, one will contain compiled code. Listen, when the developer command prompt will return first.cs, compiled it, first.exe generated. Both are same only. Source code, compiled code. Here, project and assembly are always same. First one will contain the source code. Second one will contain the compiled code. Okay, na? So both of them will have the same name and you cannot change the names also. Understood? So when should I call it project? When it is in the source format. When is it in the readable source format? We call it as a project. When it is in the compiled format, we call it as a assembly. Otherwise, both are same. Okay? Next, third one is namespace. As discussed earlier, a namespace is a logical container of types. And coming to types, what are the types we have? Classes, class, structure, interface, enum, and delegate, which are used either for grouping related types or to overcome the, I already explained all these things to you guys. For grouping, we generally use it for grouping. Second thing, to overcome the naming collision. Suppose in a project, if at all I'm going to have 2 classes with the same name, we separate them with the namespace. Okay. See, a project every project by default has a namespace which is having the same name of the project. Array oops project has oops project namespace only na, but we can change this name. Did you understand, guys? We can change this name, as well as we can also have multiple namespaces in a project. All of you carefully listen. Every project by default is a namespace which is having the same name of the project, but we can change this name, as well as we can also have multiple namespaces in a project now. All of you carefully observe. Listen to me carefully. I am creating a project called test project. I am creating a project called test project. What is the project name? Test project. What type of project? I am going to create this as a library project. What type of project? Library project. And this project contains a set of types in it now. And now I compiled it. When I compiled it, what is generated? Assembly or test project.dll. Are you clearer or not? I created a project called test project. What type of project? Library project. Compiled it. What is generated? Can I change the name? Array, come on fast. Can I change the name? No. Already said you cannot change the name. Array, cannot be changed. You can't change this name. This name cannot be changed at all. No chance. Now in this project, there are 6 classes. How many? 6 classes. By default, all the 6 classes are defined under one namespace called test project. Am I correct or not? All our 44 types are defined in the same namespace called oops project. So now also same. So here we have 6 classes. Class 1, class 2, class 3, class 4, class 5, class 6. All are present in the same namespace only. But what I said, you can change the namespace name if you want. You can change the namespace name. I want to name it as my NSP. I can change, no props. And second thing, you can have multiple namespaces. What are multiple namespaces? For example, 6 classes are there now. The first 2 classes are defined to work with SQL Server database. The first 2 classes are defined to work with SQL Server database. Okay. So I'm having a namespace here called SQL Server. The next 2 classes are defined to work with Oracle. With which database? Oracle. Namespace Oracle. And I'm defining the 2 classes here. The next 2 classes are defined to work with MySQL database. See now, all are in the same project only, but logically divided. Grouping, see now, grouping. You want to work with Oracle. Which classes you need to take the help now? 3 and 4. You want to work with MySQL. 5 and 6. You want to work with SQL Server. Class 1, class 2. Okay. Now tell me, I want to consume class 3 in my project. I want to consume class 3 in my project. Are you following me? Come on, tell me the steps. What should I do first? I want to consume class 3 in my project. Tell the names now. Step 1. Speak louder here. You're not LKG kid na. Speak louder. Add a reference to what? Which assembly? Tell the name. Tell the name of the assembly. Brainless fellows, are your eyes sparking or not? Clearly visible there, na? Tell the name I'm telling, na? Tell the name clearly. Add a reference to testproject.dll. Be clear. Okay, add a reference to testproject.dll. Step 2. Which namespace? Tell me. Use the word names. Names are there. Import the namespace. Oracle. Be clear. Import the namespace. Oracle. Now, consume the class 3 either by creating an instance or inheriting. I hope you guys are clear. Yes or not? That is what. So namespace. See, when we are adding a reference, we add a reference to assembly. When we are importing, we import a namespace. The terminology should be clear. We don't add a reference to namespace and we don't import a assembly. We add a reference to assembly. We import a namespace. Are you guys clear with the difference between the three things now? These two are always same. No difference. This is only a logical container. That's all. Okay. For grouping point of view, we just create them. For grouping, we just create them. So this is about project, assembly, and namespace. I hope with this, you guys got the clear picture how to consume the classes of one project from other project now. Till yesterday, what I shown you, consuming classes within the projects only. Till yesterday, I shown you consuming the classes within the projects only. Today, what I shown you? Consuming from one project to the other project. Either it can be the same project or it can be another project. But consuming from other projects is what we have just been explained to you in this case now. I hope this is clear for all. Okay now? Fine. Now come back here. Come back here once. Here, all of you observe in OOPS project assembly or in OOPS project namespace, how many types are there? In OOPS project, how many types are there? 44 na. 4 what 4? How many types are there? 44 na. But when I type OOPS project here, I'm getting only 5, see. What happened to the remaining 39? I imported the namespace here. All are in the same namespace only. Under that namespace, 44 types are there. But only 5 are coming in the list. What about the remaining 39? Can anyone answer this question? Why the remaining 39 are not coming in the list? They are not accessible. That only I'm asking. Why are they not accessible? Scope, yeah, scope. You need to understand the scope now. You are not able to accessible because they are not public. You are not able to access them because they are not public. These 5 classes are public, sir. Yes, you define the 5 classes public. If you want, refer to your notes. In your notes, you can clearly see these 5 classes are defined as public. Are you clearer or not? Okay. If you want, I'll show you. Watch. Go to OOPS project. In which, where you defined it? You defined all those classes in a file called test figures. Check. Figure is public. Figure is public. Cone is public. Circle is public. Triangle is public. Rectangle is public. But see, test figures is not public. What is it? Louder. Remember that internal is the default scope. I said you already now. By default, you will get internal. Internal is a default scope. Even though you don't say that, also there is internal only. Even though you don't say that, also there is internal only. But these 5 classes, we did not declare internal. We declared as public. Now, it is the time for us to understand one thing. What is it about? Scopes. It is the time for us to understand about scopes now. If you want to understand about the scopes, now, you just require to understand a concept called access specifiers. What are these access specifiers? These are also modifiers, but used for defining the scope of a type and its members. All of you listen to me carefully. These are also modifiers, but used for defining the scope of a type and its members. So what is that? We'll have a doubt. What's modifiers? What are modifiers? All keywords are modifiers here. All keywords are modifiers. Virtual is a modifier. Static is a modifier. Public is a modifier. Private is a modifier. Override is a modifier. Abstract is a modifier. Sealed is a modifier. All are modifiers only. In these particular modifiers, there are few modifiers which are used for defining the scope of a type and its members. And those modifiers are called as access specifiers. Every keyword is a modifier. In that, some modifiers are called as what? Access specifiers. We use them for defining the scope of a type and its members. Okay? C# supports the following, the below access specifiers. It supports the below access specifiers. First one, private. The first one is private. Second, internal. Third, protected. Fourth, protected internal. 5, public. 6, private protected. Private protected. Actually, that is added in C# 7. Otherwise, we have 5 guys. What are the 5? Private, internal, protected, protected internal, public, and the other one is private protected. Are you clear? Yes or not? Okay. Now, let's understand about the 6 access specifiers and the scopes of each and everything. What is the scope of private? What is the scope of internal? What is the scope of protected? What is the scope of protected internal, public, private protected? Let's try to understand about all the things. Before I jumpstart, before I explain you those, I want to confirm you few points. What is it, Listen. The default scope for a type means for class, interface, structure, enum, and delegate is. Are you clearer or not? The default scope for a type. What is the default scope for a type? Internal. Internal is the default scope. If you don't specify anything, that is internal by default. Next. The default scope for a member. Member means constructors, finalizers, properties, indexers, and deconstructors is. I already said to you here, by default, the scope of every member is private. And I also said you the default scope of a type is internal. I already explained you these two. Clearer or not? You define a type, did not specify a scope. It is internal. You define a member, did not define a scope. It is private. Any doubts? Okay. Now, let me explain you the scope of each and everything. Let me explain you the scope of each and everything now. All of you observe. I'm closing this project here. I'm creating a complete new project altogether. I'm creating a complete new project altogether. What type of project? Console app. Console app. Give a name. I'm giving the name as Access Demo 1. And whatever name you give, the solution also will have the same name already set you. Can I change the name? Can I change that name? Already said you in the last class. Yeah, you can change the name. You can give whatever name you want, guys. So earlier we did not change it. That's why our name is Oops Project. Now see, I'm changing my solution. So the name is My Solution and the project name is Access Demo 1. And you click on the next button, create. Okay. By default, you get program.cs now. Yeah, I'm writing. Namespace. What is the namespace? Access Demo 1. Inside of it, I'm writing public class program. I'm making the class public. Have you noticed it? Default is internal, but I'm making it public. Now here, I will define 5 methods. Here, I will define you 5 methods. Each method with a different scope. Point clear? I'll define 5 methods. Each method with a different scope. Every method is going to be now defined with a different scope now. Observe all of you. Just simple code only. Have a look. First method. Test1 underscore private is a private method. Just I'm printing private method, public method, that's all. Second one, internal. Third one, protected. Fourth, protected. 5, public. 6, private protected. Are you clear? My class is public and the class public contains 6 methods. Each method is defined with a different scope. Now what we are learning is scope. Scope means from where we can consume and from where we cannot consume. From where we can consume and from where we cannot consume. Okay? Before I explain that to you, I want to add one more thing here. Each and every member of a type, even if defined with any scope, is always accessible within the type. All of you read that. Every member of the class is accessible to itself. Your scope doesn't matter. Within the class, scope is not matter. Scope comes into picture only when you go out of the class. Remember that. When does scope come into picture? When you go out of the class. Within the class, scope will not be mattering now. So that's what. Each and every member of a type, even if defined with any scope, is always accessible within the type. Within the type. That is, restrictions comes into picture only when we try to consume them from. Understood? When will restrictions come? When you try to consume from other types, restrictions will come. But within the class, no restrictions now. Okay? To prove that, I'm writing this code. Watch. Static void main. create the instance of your class. What is that? Program P is equals to new program. Guys, all of you watch it. All the 6 methods are accessible to you. IntelliSense shows means that's accessible to you. All the 6 are coming in the list or not? Means all the 6 are accessible to you. The first one is a private method. Second one, internal method. Third, protected method. 4, protected internal method. 5, public method. 6, private protected method. Console dot read line. Is it clear? Do anyone have any doubts? I did not show you anything here, guys. I defined 6 methods. I called the methods. But these methods are defined with 6 codes. Any doubts? Online students, not response, no response. Okay. When will restrictions come? When will restrictions come? When you try to consume them out of the class. When you try to consume them out of the class. Now, come on, guys. Can I call the methods of this program class? Can I call the methods of this program class from another class now? I talked in English only. Can I call the methods of the program class from another class now? Yeah, we can. How many ways? 2 ways. Again, you are forgetting. If I change the question, you will not answer again. I should ask you, can I consume the class? Then you will answer. If I change it, you will not able to answer again. We can consume, na? How many ways to consume? 2 ways. 1, inheritance. 2, instance creation. You can consume it in 2 ways, inheritance and instance creation. Watch it. Observe. I am adding a new class in the project. I am adding a new class in the project. I will name the new class as class 2. What is that? 2.cs. 2.cs. And you guys watch. Class 2 is going to inherit from program. Okay, na? How many methods are defined in program class? 6 methods. Correct? How many? 6 methods. Now you are inheriting and consuming. When you are inheriting and consuming, see when I say T dot, these 6 methods are not accessible to you. Watch it. Look at, guys. What is not accessible? Concentrate. What? Louder. Private is not accessible. What is not accessible? Can you understand the scope of private? Arey, can you understand the scope of private now? What is the scope of private? That is accessible only in the class now. Not accessible out of the class. It is accessible only in the class. Not accessible out of the class. Watch. 2 is accessible. 2 is accessible. Next. 3 is accessible. 4 is accessible. 5 is accessible. And also 6 is accessible. Are you clear? What is not accessible? 1. 1 is private. Now, can you tell me what is the scope of private? Members, listen, members that are declared as private in a class or structure are accessible only within the type under which they are defined. Not saying class, it can be a class or structure also. That's way within the type under which they are defined. Okay, and listen, the default scope for members of class and structure is private only. By default, the members of class and structure are private only. Whereas, remember this, it is public in case of, we already learned it, the default scope for the members of interface is public. Are you clear? Next, we can use private only on members, but not on, you cannot define a class as private. You cannot define a structure as private. You cannot define an interface as private. You can only declare members as private, but not types as private. Is that clear? Anyone, any questions? Read it. Any questions from anyone? Okay, now private clear? Okay, next. What is the second way? This is child class, guys. This is a child class. What did you understand now? Consuming members of a class from child class defined in. Are you clear what I shown you? Consuming members of a class from child class defined in same project. Okay, now? Next. What is the second way we can consume the members of the class from another class? One is inheritance. Second option. Yeah, you can call the 5 methods. What is the second way you can consume a class from other class? Yeah, creating a instance. Adding a new class, all of you. And I am naming this class as class 3. Now in class 3, I want to consume the members of the class program. So what I'm doing, I'm not inheriting. I am creating the instance. Which class? Program class. Now after creating the instance of the program class, I want to call the methods. So all of you observe, what methods can you call? Internal, public, protected, internal. What cannot be called? Private discussion completed already. Discussion on private is already completed, out of the class, not accessible now. Still, what is not accessible? Protected. Third one, private protected. Ignore private protected now. Protected is not accessible. What did you understand from that? Protected is not accessible. What did you understand from that? Accessible only to child class. Yeah, put your brain. Is it a child class? In class 2, is it accessible? But in class 3, it is not accessible. Means what is the meaning? It is accessible only to child classes. Is a non-child class. Understand? This is a non-child class. What is the difference between 2 and 3? 2 is consuming the members of a class from child class. 3 is consuming the members of a class from. Is it clear? Non-child class defined in same project. You have a non-child class that is defined in the same project basically. Are you clearer? So let's understand about protected. Members that are declared as protected in a class are accessible only to its child classes. Only to its child classes. That is, a non-child class cannot consume or access. Is it clear? Okay. We can use protected also only on members, but not on raid. Is that clear, all of you? So from where you can consume? We can consume it only from the child class, and you cannot consume from any non-child class. And all of you remember this point. What is that? What is that? Yeah. Only to the child class, only the accessible. Right now you understood this is a non-child class. This is a non-child class. So P dot 4 is 2 is accessible. 2 is internal. 4 is accessible. But internal. 5 is also accessible. One more thing not accessible. What is that? Private protected. What is that? Private protected. What is that private protected? Let me explain you. What is private protected? Say, private protected. All of you, I'm just correcting this protected a little bit. Members that are declared as protected in a class are accessible only to its child classes, which can be defined either in the same project or other projects also. So you understand here, members that are declared as a protected in a class are accessible only to its child classes, which can be defined either in the same project or in other projects also, Clearer or not? That can be defined in the same project or it can be defined in other projects also. What is the defined in other project? Yes, guys. Here, for that reason only, I am pointing out. When I am typing here, I am typing it very clearly. What is it? Consuming members of a class from child class defined in. Tomorrow you can have a child class in another project also. Did you catch my point or not? Tomorrow you can have a child class in another project also. And class 3, consuming members of a class from child class defined in same project. Means tomorrow you can have a Tomorrow you can have a non-child class in another project also. Point clear, all of you? Yes or not? Now see, if you understand protected, you can consume it from the same project as well as other project also. Then what is private protected? Members that are declared as private protected in a class are accessible to only to its child classes. Did you understand? Did you understand the difference? What? Private protected means child classes in the same project. Protected means child classes in the same project, child classes in another project also. Okay, na? Child classes in the same project. Here, child classes in the same project and child classes in another project also. Okay. For example, all of you have a look. Just a second. Have a look, all of you. Just a second. If you observe it, now in this solution, look, concentrate. In this solution, I'm adding a new project. Console application. I will name it as Access Demo 2. Access Demo 2. So you observe it, you've got a new project now. How many? Under the solution, I have 2 projects. Access Demo 2. Here also we have a class called Program. Confusing again. Here program, confusing. So here I want to name this class as 4. What is that? 4. When you want to rename, generally rename the file, guys. Automatically class also will be renamed. 4.cs. So 4.cs. Now I want to consume the methods declared in the program class from class 4 now. Understood or not? How can we consume? Inheritance or instance creation? Anyway, 3 steps. Step 1, add a reference. Step 1, add a reference. Right click, add project reference. Come on. Browse. C# 10. My solution. Access Demo 1. Bin. Debug. NAT 6.0. Access Demo 1.dll. Reference added. Click OK. So you can observe the reference of Access Demo 1 is added to Access Demo 2. Okay, now? And now, guys, watch. This is class 4. This is class 4. Which namespace? Perfect. Access Demo 2. Okay. Class. What is the name? 4. Inheriting from which class? Program. Where is it? Access Demo 1.program. Sir, no need to import the namespace. You can import it here. One time only, na. Directly you can prefix off. When you want to write 4 times or 5 times, import it. When you want to write 1 time, prefix it. No issue. Again, no need using 1 time only. Now tell me, is class 4 a child class of program or not? Tell me. Then what is the difference between class 2 and class 4? Class 2 is a child class defined in same project, and class 4 is a child class defined in another project. I hope you guys are clear. Yes or not? So let me write the description for this. I'll copy, come here, and I'm pasting it here. Consuming members of the class from child class defined in another project. Same way in this project here, I will write the code in that. Hold on. In this project, I'm going to write a new class here called class 5. What is that? Class 5. In class 5 also, I want to consume the members of the program class. In class 5 also, I want to consume the members of the program class. But how I want to consume? By creating a instance, not by inheritance now, by creating a, say, static void main, create the instance of the program class here. Program P is equals to new program. Did you understand? Class 3, class 5 are same now, non-child classes. Difference? Non-child class of same project, non-child class in different project. Got it? Class 3 is a non-child class defined in same project. Non-child class defined in same project. Class 5 is a non-child class defined in another project. But both are non-child. Totally 5 scenarios you understood? What are the 5 scenarios? First one, guys, consuming members of a class from total 5 scenarios I shown you. Consuming members of a class from same class. Consuming members of a class from child class in same project. Consuming members of a class from non-child class in same project. Consuming members of a class from child class in another project. Consuming members of a class from non-child class in tomorrow when you work in the industry, you will come across these 5 scenarios only. Nothing outside of the 5 again. Are you clearer or not? Anything should come within this particular 5 only. Okay. 4th case and 5th case I did not complete. I defined it and left out. And 2 more scopes we need to understand. Sorry, 3 more scopes we need to understand. What are the 3 more scopes? Internal, protected internal. I'll explain you tomorrow. I'll explain you tomorrow about these 3 scopes: internal, protected internal, and public. Okay? Stop here. We'll see tomorrow.
Recording stopped.